Today we'll be covering some common problems involving probability and time conversion. We'll explain each problem step by step with visual demonstrations to help you understand the concepts. Let's start with our first problem about time conversion. A clock shows the time as 10.76. We need to find how many hours and minutes this represents. This is a common type of problem where we need to convert decimal time to hours and minutes. Let's visualize this with a clock face. First, we need to understand that in a decimal time format, the whole number part represents hours, while the decimal part represents a fraction of an hour. So the 10 means 10 hours. For the decimal part, 0.76, we need to convert this to minutes. Since 1 hour has 60 minutes, we multiply the decimal part by 60. Let's calculate. 0.76 times 60 equals 45.6 minutes. Therefore, 10.76 equals 10 hours and 45.6 minutes, which we can round to 10 hours and 46 minutes. Let's move on to our second problem about probability. Rajesh rolled a dice 15 times and counted the odd numbers. You rolled a dice 20 times and counted the even numbers. What is the difference between the expected number of counts? This problem asks us to find the expected difference in counts when we're looking for odd versus even numbers on a standard six-sided dice. Let's first understand what we're working with. A standard dice has 6 sides numbered 1 through 6. The odd numbers are 1, 3, and 5, and the even numbers are 2, 4, and 6. First, let's calculate the probability of rolling an odd number. There are 3 odd numbers out of 6 total outcomes, so the probability is 3 divided by 6, which equals 1/2 or 0.5. Similarly, the probability of rolling an even number is also 3 out of 6, or 1/2. Now, for Rajesh, who rolled the dice 15 times, the expected number of odd rolls is 15 times the probability of an odd number. 15 times 0.5 equals 7.5. For you, who rolled the dice 20 times, the expected number of even rolls is 20 times the probability of an even number. 20 times 0.5 equals 10. Therefore, the difference in expected counts is 10 minus 7.5, which equals 2.5. Let's move to our third problem about probability in multiple choice questions. A multiple choice question has 4 options labeled A, B, C, and D. You choose option D. What is the probability that your answer is correct? This is a straightforward probability problem where we need to find the likelihood of a single correct outcome from multiple possibilities. Let's visualize a multiple choice question. We have 4 options, A, B, C, and D. Only one of these is the correct answer. You've chosen option D. Since there are 4 possible options and only one is correct, the probability of any option being correct is 1 out of 4, which equals 0.25 or 25%. We can visualize this as a pie chart where each option represents 25% of the total probability. Your choice of option D has a 25% chance of being correct. Let's look at our next problem about specific outcomes when rolling a dice. A dice has 6 sides numbered 1 through 6. What is the probability of rolling either a 2 or a 4? This problem asks for the probability of getting either of 2 specific outcomes from a dice roll. Let's revisit our dice visualization. We want to find the probability of rolling either a 2 or a 4. These are our favorable outcomes. We have 2 favorable outcomes, rolling a 2 or rolling a 4. The total number of possible outcomes is 6, since a dice has 6 sides. Therefore, the probability equals the number of favorable outcomes divided by the total number of possible outcomes. 2 divided by 6, which simplifies to 1/3, or about 0.333. The probability of rolling either a 2 or a 4 is 1/3. Let's look at our fifth problem about coin flips. A coin has 2 sides, heads and tails. What is the probability of getting heads when flipping the coin? This is one of the most fundamental probability examples. Let's visualize a coin toss. A standard coin has 2 sides, heads and tails. When we flip a coin, it randomly lands on one side or the other. The number of favorable outcomes is 1, which is getting heads. The total number of possible outcomes is 2, either heads or tails. Therefore, the probability of getting heads equals 1 divided by 2, which is 1/2 or 0.5. This can also be expressed as 50%. Let's summarize what we've learned today. We've covered time conversion, calculating decimal time to hours and minutes. We've also explored various probability scenarios. With dice, we calculated the expected number of specific outcomes over multiple rolls, the probability of specific outcomes like 2 or 4, and worked with both even and odd numbers. With a multiple choice question, we found the probability of selecting the correct answer when there are 4 options. And with coin flips, we saw the classic example of a 50% probability. These math skills are useful in many real-world applications, from scheduling and time management to gaming, statistics, and decision-making. Thank you for watching.